All right, this is the Geometry Unit 1 Lesson 4 video. This is going to take us to kind of a different view or different way of thinking about line segments. And that is going to be thinking about them as if they were points graphed on the coordinate plane. And that term should be something you know. You did a lot of this in algebra. But the coordinate plane is our x and y axis and how we kind of graph points and look at things like slope and y-intercept, things that you've done in the past. And so the first thing in this lesson is just some basic terminology about the coordinate plane. So just to kind of go over that briefly. In the coordinate plane, you have your y-axis and you have your x-axis. The y-axis is the vertical axis. The x-axis is the horizontal axis. So we have a vertical axis, the y. The horizontal axis is the x. The place where they meet is called the origin. The origin has a coordinate of 0, 0. Because it is not moved up, down, left, right from that point, it has a coordinate of 0, 0. That's called the origin. And then we can divide the coordinate plane up into 4 quadrants. And they go, starting here, they go counterclockwise: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I often see it written in Roman numerals like you see there. And each quadrant has points that are the same positive or negative combination. So quadrant 1, and you can see this here on this diagram, quadrant 1 always has positive x and positive y. That's what you see right here. Quadrant 2 always has negative x and positive y. Quadrant 3 always has negative, negative. And quadrant 4 always has positive, negative. So the first thing that you're going to have to do is, first of all, answer some basic questions about the vocabulary that I just talked about. See that here. Then you're going to have to actually find the values for certain points. And just to kind of help you recall, when we graph a point, we graph it using an x and y coordinate. The first number in any coordinate is the x value. That tells me how far to go in the horizontal direction. If it's positive, I go this direction. If it's negative, I go this direction. And then the number for the y, the second number in the coordinate, tells me to either go up or down if it's negative. And so if I have the point, looking at point D, for instance, point D goes positive 3, down 3. So 3 on the x, minus 3 on the y. Hopefully this is something you remember. So that's what you have to do for the rest, or not the rest, but the next few questions, is graph or identify the points that are graphed here on this coordinate plane. So that's number 6, number 7, and number 8. So you go ahead and practice all of that. Then we get to what this lesson is really all about. Get my notes to load. And that is these two formulas, the midpoint and distance formulas. So what these two formulas do is they take, if we were to graph 2 points, you see I've graphed 2 points right here. If I graph these 2 points, and I'm trying to zoom in so I get my negative ones to show up. Yes. There we go. If I get it to go. There we go. This point is the point 1, 4 and the point negative 3, 6. And what we're going to be doing is we are going to be using these formulas to find out the distance between those in units and the midpoint, or the point that's exactly halfway between those 2 points. So I'm going to work through a couple examples of how to do distance and midpoint, and we'll just do that together. So let me open a new drawing here. Okay, so I'm going to go back here. We're going to grab these 2 points. 1, 4 is the xy for the first, and negative 3, 6 is the coordinate of the second point. Grab all this and move it down. Now, the first thing you have to understand is when we see these 2 points, we are going to think of one of these as point 1 and one of them as point 2. And more to the point, the coordinates here are going to be counted as x1 and x2. Oh, sorry about that. y2 is what I mean. y1, and then x2 and y2. Because this is point 2, this is going to be x2, y2, x1, y1. All right. So those things are the different inputs that we're going to use in our different equations. So let's go ahead and write down our equation that we have for midpoint. Okay, this is in the notes, but I know off the top of my head. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So what we're going to do is we're going to take the numbers from this and put them in the correct places in this formula. Okay, so I'm going to actually just erase and say x1 is 1, x2 is negative 3. I'm going to put that in parentheses and we'll deal with that in a second. That's coming from x1, x2. Then I have y1, which is 4, and y2, which is 6. So let's go down. So we plugged everything in where it goes. We plugged in our x and our y, 1 and 2. And now we just need to simplify this until I get down to an actual point. So let's look at this. 1 plus negative 3. Let's go ahead and open Desmos, or if you have a calculator, you can do that as well. We have 1 plus negative 3. You can type that in directly, 1 plus negative 3. You'll see I get negative 2. So this whole thing becomes negative 2 divided by 2. 4 plus 6 divided by 2. So we know 4 plus 6 is 10. 10 divided by 2. Negative 2 divided by 2. Again, if you're not sure about these different operations, just go into Desmos or use your calculator. I just did. I'll do that again. Negative 2 divided by 2. Negative 2 divided by 2. Hit enter. Negative 1. So this becomes negative. Use a different color here. Negative 1. 10 divided by 2 is 5. And so this would be the midpoint of the 2 points from up here. So the midpoint of these 2 points is negative 1, 5. And if I go back to the graph that I had made earlier, and I graph that point, negative 1, 5, you can see that it would be exactly in the middle of those 2 points. So that makes a lot of sense. And you can always check by graphing your answer to see if it matches what you see in the graph. So that is our formula for midpoint. So let's go back and let's do these points again, but let's find out what the distance is between these 2 points. Start a new drawing. Again, my points are negative 1, 1, 4, and negative 3, 6. 1, 4, and negative 3, 6. Again, this is x1, y1, x2, y2. And then my formula is, again, coming from our notes, square root of x2 minus x1 squared. And I'm gonna write all this down for us on our drawing. So over here, we're gonna have the square root, so distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's put everything in the formula where it belongs. x2 is -3. So -3 minus x1 is 1. Just go ahead and put our square root back over there. y2 is 6. And y1 is 4. And that is squared. So all I've done so far is just put in everything for the different values that we needed. Now I'm going to start simplifying. Let's go in here. Again, d equal to the square root of -3 minus 1. No shame in using Desmos for that. -3 minus 1 is -4. Now, you'll notice I left the parentheses around that -4. That is key. You need to square -4 with parentheses, and I will show you why in a minute. 6 minus 4 is 2. All right. Make that 2 look a little bit less crazy. There we go. All right. Let's jump on to our next step. D equals the square root of, -4 squared. Now, let's talk about this. There are two ways I could do this. If I just am in a hurry and I go type -4 squared, I get an answer of -16. But that is not correct, because when the calculator does -4 squared, it is doing 4 squared and then putting a -1 at the end. But we don't want to do that. We want to square, -4. So you need to type it in the way you see in the second example. So we get an answer of 16. 2 squared, same thing as 2 times 2, but 2 squared is 4. Oops. There we go, 4. Keep going. D is equal to the square root of 20. Now, 20 is not a perfect square. So you could leave the answer as square root of 20, or you can come over here to Desmos and do the square root of 20, or your own calculator, which is about 4.47. So we'll say that equals about 4.47. So either of those are good answers. It looks like in the problem, they want the answer in terms of square roots. So they don't want you to do the decimal thing. They prefer the answer to look like that, or in our example, like this with the square root actually in it. Okay, so that's your example of how to do distance formula. And that is the basic rest of the lesson. You have 2 examples there, or 2 problems you have to do. You have line segment AB, line segment RS. You have the points written out for you, and then you're going to find the length and the coordinates of the midpoint. Formulas are in the notes for you. Make sure you follow along with my examples. If you have trouble with any of this, reach out to me and we'll set up a time for tutoring. Otherwise, good luck, and I will see you on the next video.